All right. Howdy, everybody. We're going to go ahead and get started on the next session. Piggybacking off of the last panel around standards development, we are going to discuss today a specific set of specifications that we've been developing as part of the Carbon Data Specification Consortium, specifically around the new discovery, registration, and customer data drafts that we have developed as part of CDSC Working Groups 1 and 3. So as a little bit of background, the organizational structure, we have the Linux Foundation, we have LF Energy, which is this conference. Within LF Energy, there is a standards and specifications committee. And within that standards and specifications committee, there is a consortium called the Carbon Data Specification Consortium. And within that consortium, there are 3 working groups. The first working group is around standardizing discovery and registration protocols. That's called the Connectivity Working Group. The second one is the Power Systems Data Working Group, which focuses on power systems data models. And the third one is the Customer Data Working Group, which focuses on standardizing access to customer data. So today we are going to be diving into the specifications for the first working group and the third working group. The reason why we're going to be doing that is because originally there were 2 working groups, the Customer Data Working Group and the Power Systems Data Working Group. And as part of the Customer Data Working Group, we actually developed the server metadata and client registration protocols that is more universally applicable than just customer data, so we split it out into its own working group. Okay, I'm going to hand it over to Eloi. Oh, by the way, my name is Daniel. Sorry for not introducing myself.
Hello, everyone. This is Eloi from Flexidao. So actually, when we talk about utility data access at the scale level, it's a challenging topic today. We encounter different barriers, different problems. If you see a little bit of frustration when I'm talking about them, because if we as Flexidao, we've experienced them directly. So I'm going to link those challenges with the components that we try to incorporate into the specifications to make sure that we reduce these barriers. And the first one is what we call discovery. Right now, utility data is very fragmented. It's held in different sources, in this case, utilities or other central entities. And it's challenging as a business or an energy service provider to go one by one and check what they offer and how they offer. So within the specs and with the discovery, we'll make sure that utilities and central entities can register there and can say to users, look, we are here and this is the data we offer. Then, once you identify the utility that you want to get integrated, it's very challenging to know exactly sometimes the requirements, what are the processes to get integrated. So the next component, it's in terms of registration and connectivity. So making sure that it's a smooth process for companies to get integrated to the utilities listed in the specs and in the discovery phase, and check all the requirements that are needed to get integrated. Once you are integrated and connected to a server or a utility, you need to follow an authorization process. Of course, when we talk about utility client data, it's a private data, so we need to follow a consent procedure. So we make sure that within the specs, all this process it's followed up. And today, this is also an issue. There are many processes for authorization, from authorization letters to more digitalized process, so we try also to standardize this. And finally, once you get authorized by your client or the end user, it's when you got access to the data. So we have the data access component, which defines all the protocols, the formats, the set of APIs that enable users of the specification to get to the data that they're looking for to develop their business. And basically, following up with the introduction of Daniel, so that's how we divide the different working groups. There is one working group we call connectivity that it joined for the discovery and registration and connectivity components, and 2 specifications, the server metadata and the client registration. And as Daniel saw, this is more general overview, and then we focus on the working group customer data, that it's more linked to utility data with authorization and data access components. Back to Daniel.
Thank you. So in these specifications, we have a set of terminology that we like to use. First up, there is the server. The server is understood to be the utility or the centralized entity, a TSO, a DSO, that sort of thing. Basically, whoever is offering access to the APIs that you're registering with, that you're trying to get data from. Secondarily, you have the client. The client is the third-party application or company that is interacting with the server. So think of it as the API user. And lastly, there's the term API, which we are going to use frequently during this whole process. APIs are basically a place or an endpoint or a URL where you can send a request and then get back information. You can also do other methods. So there are methods for our APIs that we define. The default one is a GET, which means you get information from the server. Post means you're sending information to a server to do something like create a piece of information or an endpoint. There are other methods as well. And so when you see these throughout the presentation, these are the methods and endpoints for the APIs that we are defining. Okay? So as a little bit of a demonstration here, we have a client, which is a third-party application, and a server, which is a utility. And for example, a client could send a request to the server with a GET request of get all of the grants that I have been granted. So these are the authorizations that I've been granted access to. And the server will reply with the grant data if properly authenticated. Similarly, if you want to get a new token, you can post to the token API and get back the created token in a structured format. So it's very similar to, like, say, opening a web page or something like that, only the information you get back is in a structured manner. So that's how the APIs work. So our specifications define a set of APIs. For the first specification, the server metadata, this is about the discovery phase, so figuring out what a server, what utilities offer what sort of capabilities. We have a API endpoint called the get well-known Carbon Data Spec, and the .well-known endpoint is a common use endpoint for web servers to advertise their capabilities. This is used in many, many other protocols, not just the CDSC. And the information you get back looks something like this. So this is kind of that structured format. So it's not a web page, it's a structured format in the JSON format. And I want to call out several different features of this API. First off, the fixed URL. So you can basically crawl the internet looking for this URL. And as utilities publish these capabilities on this URL, you will automatically be able to discover them. And so that's one of the benefits, is you don't have to have a place where utilities have to go and post, oh, these are my capabilities. You don't have to collect that. You can just crawl the internet, see if this exists, and as utilities come online with this specification, they'll naturally be discovered. The next part is information about the format, so versioning, updating, that sort of thing. The next piece or chunk of information is descriptive information about the utility. This is what the utility does. This is where it sits. This is a description. These are some links. The next part is the important part. It is a list of capabilities. So this is the capabilities that the utility is advertising to offer. So this is, this is what our coverage is. This is what sort of data access we offer. This is what sort of like power systems data access we offer. This is if you're using it for other protocols like operations and controls, this is where you would potentially add, this is what you can do or interact with these APIs. And the last part is an extensible section that describes, okay, now that you know that you have these capabilities, here's where you can go to learn more. So for example, for customer data access, this would be the link where you can find more information about how to register with that utility. Okay, so that's an overview of the server metadata APIs. Really, there's only one endpoint that's the primary focus of this specification, but this is how you establish the ability for a very fractional market to be able to discover, a third-party clients to be able to discover what utilities offer what information. So here we go. That's basically the summary there. It is a way for utilities to advertise and third-party apps clients to discover. The second specification is about, okay, now that you know a utility is offering data access, how do you actually register with it? Right now, the kind of existing ad hoc, it's a very ad hoc world where you gotta like have a special registration form for each utility. What we're doing here is we're defining a set of APIs by which you can establish connectivity, secure connectivity, and approval from the utilities in an automated fashion so that you can write apps that, when they automatically discover, can automatically register. So the extension that is going on here is we're adding an OAuth metadata endpoint to the previous specification. So in the capabilities, we're adding an OAuth endpoint, as well as an OAuth metadata URL, where you can find the OAuth capability. And then in the URL that you have in the OAuth metadata, this endpoint extends RFC 8414, which is a common OAuth server metadata protocol. And so this is something that is very familiar to a lot of, for example, single sign-on providers. If you've ever like signed in with Google or something like that, this is a structure that is familiar to those software providers. We extend that specification to add various information, specifically API-based endpoints for registering, so you don't have to go to a website to register. You could automate the registration process. And secondarily, what information you are required to submit to register, whether or not you need to submit a contact information or your redirect URIs, that sort of thing. Secondarily, transparent disclosure of what scopes are offered. And so scopes in the OAuth terminology is basically what you get access to in a granular fashion. You get access to account data, you get access to usage data, you get access to these various things. The scopes are where this is disclosed, hey, this is what we offer access to, and this is how the means by which you can access that information. For example, you need customer consent. Okay, that's disclosed here. So when you have that information about how to register, there's an API to register, which is the post. You're submitting your registration to that API. And when you register, you gain access to another suite of APIs. And these are all about your management of your registration and configuration of your registration. And so these are all defined in the specification that allow a client to register and then manage their registration in an API-driven way. So you don't have to go to a settings page or anything like that. What that allows is for the automation of registration and integration with utilities. And so that's a major leap forward from the status quo now. There is the client management and settings APIs, the communications APIs. So this is very interesting, where there's a set of APIs where the server is required to communicate significant or information specific or required communications with the client via these APIs, which means that you don't have a dashboard with like a little red dot for your notices, that sort of thing. When the server is going to go down for maintenance, that can all be automated via these communications APIs. And then lastly, the ability to manage your tokens and secrets. There's an API for that as well, so that you can securely rotate your secrets or issue new secrets for establishing secure connectivity. So these are the sets of APIs you get with that. In addition, there are defined endpoints for access to the authorizations or grants that you've been given. So when you get an authorization from a customer, you'll have an API for being able to see that or see all the previous authorizations that you've been given, so you can browse that as well as a directory for servers to be able to publish the list of clients that they have approved. So like a publicly available list of third-party apps that have integrated integrated with them. There's a set of APIs available for that as well. So the summary, the second specification as part of the connectivity working group standardizes how third-party companies and apps can register with utilities and other central entities, configure their profiles, communicate messages, and manage their secret keys and credentials. And so what we have here with this set of specifications is we have a generic protocol tailored to the energy ecosystem that provide utilities and other central entities with an open standard for offering secure API access and capabilities to external third parties' apps. And so what that means is that if you are a utility and you, as part of your programs, your rebates, your load management, your grid flexibility, your DERMS, all of these sort of things necessarily require some sort of connectivity to the outside world, to outside companies or businesses, especially if you're doing like IoT management or curtailment or anything like that. All of these things require some sort of bootstrapping of a secure communication. And what we have written here in these specifications is a protocol by which you can offer that secure connectivity in a standardized and open manner. So in the customer data working group, we needed that protocol in order to be able to like give access to customer data because it's private information. It requires customer consent. And so we wrote these and we're like, well, Alex actually from LF Energy, he said like, this is more generically applicable to than just customer data. This should be useful to load management programs, to all of these things that require this secure communication. And so we split it off into its own set of working groups so that other specifications and protocols that need secure communications between central grid operators and external third parties, they're encouraged to use these specifications as the basis for establishing that secure connectivity. And so these are the open specifications. We are highly encouraging of other specifications to use these and just say, hey, we're defining this thing and we're going to assume that you have a secure token using this protocol. And then you can use our protocol as that method, as the authentication method for that protocol. Okay? And so, let's see here. CSC. Oh, I went backwards. Let's go forwards. So, now we get to the real meat of like why this working group was started was the customer data part. Okay? So first off, the customer data from a utility is necessary to do a significant amount of use cases. We started off with the use case of carbon accounting. If you are trying to, measure the carbon impact of this building, you kind of need the usage data for this building. And then you need the grid emissions data, and you marry the two together, and you get your carbon impact of this building. That's the basic equation. And so one half of that information is the private energy usage data for this building, which is the customer's information. And so for a utility to offer API access to that, that's a very complex thing because it's the customer's data. It sits in the utility's database, but the utility won't release it to just anybody. You can't just walk up to the utility and say, hey, give me this information. Even if you're, a big application, like a big analytics platform or something like that. And so you need customer consent in order to open up access to that. And you need specific customer consent. You need a customer to say, I am authorizing this, say this hotel is authorizing this company to access this information, not I get customer consent to release it publicly. I mean, they could do that, but in general, it's a one-to-one sort of authorization flow or a one-to-set group. So I'm authorizing my bank to access it as well as this analytics platform, etc. And so our specification extends the scopes for the registration specification to say, if you want access to this customer data, you need to get customer consent, and that is built into the OAuth specifications, which is why we're going with the OAuth specifications, because online authorization is a kind of a solved problem in other industries, and so we're basically taking that. It's nothing new. We're taking that and applying it to the utility space. We're adding scopes for that, and we're allowing clients to use those protocols to request authorizations from customers using that server's authorization setup. So a app can have like a little pop-up where it's an OAuth authorization screen where you can log into your utility account and click I approve, and then it pops back into the application with that code exchange using the OAuth standard. And so this is a known process in many, many other, like healthcare and finance, et cetera. So we're not inventing new authorization protocols. We're using existing ones, and we're just defining what you can request. So some example authorization request scopes. You can request the account details, so this is my list of accounts. Or you can say, oh, I just want to share a subset of those accounts, maybe a specific location of a manufacturing facility. Secondarily, bill information. So if you're doing financial analysis or some sort of dashboard for a user for building management, be able to see the bill amounts that you have for a specific utility customer, as well as detailed usage information. So for smart meters, that's maybe 15-minute interval data you'd be able to authorize access to as a customer, so you can see that information and integrate it into your carbon accounting applications or feasibility analyses, that sort of thing. And these scopes can be historical or ongoing. And so for usage data, you can say get the last 2 years of usage, and you can get ongoing access to usage. So maybe day behind data perpetually for 3 years into the future, for example. So you can integrate this in with your building monitoring systems, with your measurement and verification systems, that sort of thing. Many other scopes are also enumerated. That's part of the specification, is basically outlining the common use case scopes. These are extensible, meaning that additional specifications in the future can be added to it. So for example, access to EV charging information or EV control information, those can be extensions on top of these customer data base specifications. So a little bit about the APIs for the customer data specification. You have your accounts API, so this is information about customer accounts. These are your accounts, these are your service contracts. So service contracts are like, the electric service for this particular meter, or the like many buildings have multiple meters on them, so it's multiple service contracts under one account, that sort of thing. Here, meter metadata, so that's information about your actual meters, whether or not it's bidirectional, where your meter service points are, that sort of thing. So different types of things. If you, for example, have 2 meters, one for solar and a feed-in tariff, and one for consumption, you can define those out here or provide access to those there. We have a set of APIs for customer billing data. And so that's for both bill statements and the sections within each bill for each service contract. A lot of times customers don't necessarily want to share their full bill statement, which may have a carried balance or their payment history, that sort of thing. And they just want to share that one section. This is my cost profile for this electric service at this one location, because when you're doing an evaluation for installing EV charging or something like that, you'll only want to share that specific piece of information. That's available as a limited scope on the APIs. The energy usage, so this is compatible with both AMI and traditional manually read meters. And so if you have usage on a monthly basis, you can describe it here, as well as usage on a granular basis. So if you have AMI meters, 15 minutes or hourly intervals, you can you can disclose them or get access to them there. What this does not have, I want to clarify, is a streaming real-time API. And so this is not necessarily, streaming real-time data is not necessarily in scope for this customer data specification. There may be extensions in the future that do outline a set of APIs that offer streaming access, but in general, utilities collect the AMI information, they validate it, and it becomes available on kind of a nightly batch basis. That is the sort of information that you would be able to get using this API in a default scenario. We also have an aggregated groups API, commonly for building benchmarking. You will have a whole building usage data, so this is the usage for this entire building. In order to do some sort of benchmarking purposes for, in the US, it's the Energy Star program to rate a building on its energy efficiency. If there are enough meters in that, this is a way that you can say, we are combining this whole building into a single set of usage, so the usage segment is for the whole building, not a specific set of services, okay? Or a single service. And so this is a method by which you can have aggregated usage data disclosed on this API as well. And then lastly, associating that usage data with energy attribute certificates. And so as a utility, if you are doing green tariffs or individual PPAs for customers, they may want to know what EACs are associated with their usage so that they can do their own verification on the registries of those productions, those green productions. And so this is a way to disclose or associate the usage with specific EACs that have been purchased by a utility on behalf of the customer. So the utility is the one canceling the EAC. But they are then internally applying it to a customer, and this is a method by which the customer can see, or the app provider that's working for the customer can see that information. So in summary, about the customer data specification, it standardizes how a third-party company can securely request authorization from customers and access to their account, bill, and usage data, and then when authorized, can securely download that information in a standardized format. And so this is kind of a drop-in, off-the-shelf, available open standard that can really benefit the automation and scalability of analytics apps and integrations with customer data. Okay, I'm going to turn it back over to talk about use cases.
All right, so now we'll provide a couple of examples of potential use cases and companies that will benefit the implementation of the standards. And first of all, Flexidao, it's where I work. So at Flexidao, we develop software solutions to energy buyers to provide them with a comprehensive overview of their clean energy portfolio for optimized carbon accounting. So in order to provide that and to enhance next generation procurement strategies, such as 24/7, we need access to granular data. So the CDSC specifications will help us unblock and empower our use case that we offer as a company, that it's linked to EAC's management portfolio, also clean electricity portfolio management and monitoring of renewable contracts, and also scope 2 reporting focus for electricity. And it's not only about meter data, as Daniel was saying with the scopes. So we also sometimes need billing information or the justification of those clean energy contracts in terms of energy attribute certificates. So we are trying in the working groups to define what are the scopes needed from different use cases and different companies. And that's what we brought into the working group. And then another example is Google. So with the goal that they established in 2020 of becoming 24/7 carbon-free energy by 2030, again, there's importance of getting access to more granular data to be able to do hourly matching, so time and location-based matching. And having that data enables different use cases for Google. So more accurate carbon accounting, moving to more granularity. Also actions on the next generation procurement, or making decisions on, okay, to become more 24/7 carbon-free energy, I need to buy this type of contract because I have this visibility on when I'm missing some production to be matched. And also some other cases, such as grid flexibility, having close to near real-time data on a more granular level can help unblock some other use cases, such as load shifting or demand response. And then also develop some tools and solutions that link to the needs of the power system in terms of grid planning. And Google is a great example because it has global operations. So it's crucial to have a standardized process and formats to unblock this issue of getting utility data access. And they are actively participating in the working groups as well. So that was 2 examples of use cases and companies that are onboarded and providing our feedback into the CDSC. Thank you. Back to Daniel.
Yeah. Okay, so just to wrap up, there are several different kind of conclusions that we would like you to kind of come away from this talk understanding. The first is the connectivity working group has written open specifications that enable utilities and other central entities to securely connect and communicate with external third parties for many purposes. The second is the customer data working group has written open specifications using the connectivity group's specifications as the basis to establish a secure means of sharing customer data from utility ecosystems with customer consent included. And the last one is other working groups are encouraged to adopt the connectivity working group specifications as the basis for establishing connectivity for their own protocols. So if you have a protocol that needs secure connectivity, you can use these as your kind of drop-in, here's how you register, here's how you do token exchange, all of that sort of stuff, so that you don't have to invent the wheel yourself on that. And so this is, and an example of that is the customer data specifications. And so you can use that as kind of a reference for it as well. So these are the 3 main conclusions. As far as timeline for the working groups, the remainder of the year, we are working on feedback of the specifications. There are open pull requests on the GitHub repositories for that. And we have working group meetings every other week where we are going through talking about discussion points for various aspects of the specifications that need a little bit of clarification. Additionally, the company that I am with, UtilityAPI, is working on a prototype demo implementation of a server that implements the customer data specifications. And so this is a way to show, not tell, show people, oh, this is what you can do with it, this is a demo, that sort of thing, so that we can start to widen the sphere of people who are paying attention to this, and for utilities to potentially evaluate adopting it. 2025, next year, our goal is to establish some pilot implementations of this set of specifications for customer data, as well as potentially individual deployments of the connectivity specifications for other purposes, as well as, once we have those pilot implementations, starting to the process of getting it standardized through ISO, which we talked about the last session. So onwards, the goal is to ultimately have these specifications as part of the ISO ecosystem, as well as available via the LF Energy system. So these are the websites where you can learn more. You can also just go to carbondataspec.org, and it links to these websites. So this is where you can find more. If there's one ask, join the mailing list, join the mailing list, join the mailing list. That's the best way that you can stay involved or up to date with these specifications. Everything is open, so you can visit the GitHub repositories and the websites and read more about it. That's the benefit of LF Energy, is nothing here is secret, and it's a very collaborative place. And that is an overview of our presentation. I believe we have about 5 minutes left. If anybody has any questions, or I can go back through, and we've sped through 3 specifications very, very quickly. So hopefully that was a comprehensive overview or a deep dive into the actual mechanics. It's not just talking points. This is how it actually works. So thank you. Yes.
Daniel, which group of the utilities are you usually working with to actually implement this standard?
Yeah. So when we have worked with utilities before to deploy data access APIs, there's generally 2 main divisions within a utility that is paying attention to this. If a regulator has mandated data access APIs, it is going to be the IT team at the utility that is charged with doing it. And so that has happened in several jurisdictions in the United States, as well as Canada, is where we have done those sort of projects. And in those sort of scenarios, the IT teams at the utilities are just looking to fulfill the mandate. They're tasked with that. That's their project. And so the level of, I guess, interest in making sure or understanding the users or the use cases that this will be applicable to is more left to the regulator and less the IT team. The IT team is just there. And so we work with the IT team, but we really, our audience that we're trying to please is the regulator who wants this thing to work. And so our expertise is being able to do both of those things. But in general, the people we're working with on the, hey, how does this work? It's going to be the regulator, not necessarily the utility. The utility, you just work with their IT team. In other situations, a utility is making these APIs available for their own purposes, for their own incentives. So we have several deployments in the US of APIs that are deployed voluntarily without a mandate from a regulator. And in those cases, you're working with whatever program division wants those APIs to exist. And so, for example, there is a load management program at a utility in California that program implementation division, or the innovation team within that utility, they're the ones that we work with to establish the benefits or the behaviors of the APIs, and they're the ones who are basically, the funding is coming from their division, right? And so those are the 2 kind of ecosystems, either program specific for voluntary implementations or the regulatory and structure, as well as the individual IT team at a utility. Great. Any other questions? Yes.
You may not be able to answer, but can you talk about the licensing of the open standard? Are there going to be patents involved? How are you going to deal with patent grants going forward? So
let me actually go all the way back to the structure. So the way it works with LFESS, which is all the way back, here we go. So LF Energy Standards and Specifications, or LFESS, is a joint development, uses the JDF framework, joint development framework, and that has basically, in order to get language into the specifications, you have to sign an agreement saying that the information you contribute is free of licensing requirements, etc. So these specifications are truly open. You can implement them without any sort of royalty or patent claim or licensing requirements in order to implement them. And so that was kind of established early on, and why you have this very extravagant tree of structure here. Okay. Yes?
Are there other people who build standards separately, utilities doing their own things? Like, what's the competition?
So there is, for customer data specifically, or usage data specifically, there's an existing standard in the US and Canada that is written by an organization called NASB, the North American Energy Standards Board. It's commonly referred to as the Green Button specification. I was actually the vice chair on the board of the Green Button Alliance for 7 years, and so I've been in this business for a while. The UtilityAPI, we actually deploy Green Button certified systems for utilities, and so that's what I would see as kind of like the existing specification. That if a utility in the US and Canada want to deploy a set of APIs for customer data, that specification does not cover nearly the scope that these specifications do. It doesn't cover, for example, registration, discovery, various implement EACs, that sort of thing. And so it was written over a decade ago, and so it's kind of limited in scope as far as the evolving ecosystem, and it's also not open. So you have to purchase the standard, you have to agree to a set of licenses, et cetera, and so it's not, a third-party client can't just go read the spec, you have to buy it. And so that's another kind of differentiator from here for that. We have also seen, I would say the majority of APIs that utilities offer to either third-party clients or vendors in order to establish connectivity are completely ad hoc. Hey, here's your documentation for this one utility. This is how we get it. We're gonna send you a separate email with your token in it, and it's a secure email, even though it just sends you an email and it sends you a verification code to it. And that's the way you get access to the data. And a lot of times utilities aren't even that sophisticated. What they'll do is they'll set up an SFTP site and give you all the customer data as a vendor, and you just sign a contract saying you won't share it with anybody. And that's the means by which you get access to this secure data. Well, we need to evolve beyond that. We need to establish a way of scaling that connectivity, because really when you have those ad hoc methods, you can't scale that. You can't automate that. And so really to get the kind of grid flexibility that we need in order to smoothly operate a grid with renewables, you really need that sort of automated connectivity and registration capabilities to be able to integrate as many resources as you possibly can to help you out.
And to add on that, the situation in Europe, so it's not as fragmented. It depends a little bit on each country and potential data management models or data hubs that are implemented on a country level. But there are some projects going on under Horizon Europe funding program. One example is EDI, European Distributed Data Infrastructure for Energy, which tries also to standardize or build up the interoperability of collecting energy data and meter data among different member states and countries. So I suggest also to have a look on that. Could be interesting.
We're a minute over, but I believe lunch is next. And so happy to continue answering questions, but we can also just go to lunch. Okay, thank you everybody.